So, hi guys, I'm Steven FKME, and today we're gonna plot the exercise 1-1 of the radar plotting sheet of uh, navigation. So here we have a problem. So our ship's course, we have no ship's course and also speed information in this problem, but we have two detected targets or positions from point R and M. So point R is 0, with a bearing of 093 degrees true and a distance of 10 miles. And the next is point M, which is 06 and with a bearing of 087 degrees true and distance of 8.0 miles. So we're gonna find the CPA distance, CPA bearing, time of CPA, and speed of relative motion, as well as the DRM, or the direction of relative motion. So the first thing, we're gonna plot the point R and M. So for the point R, we're gonna locate 90 degrees 90 degrees from this position. So 92, 93. And then with a distance of 10 miles, so 2, 4, 6, 8, 10. So here, so label this one as point M. So point R, and 0 R's. So next is point M, which is 06 with a bearing of 87. So 80, 85, 86, 87. So here, 2, 4, 6, 8 miles. Then label this one as point M, and then 0600. So here, we have plotted the point R and M. So next thing is draw your relative motion line. So from point R to M, connect that one, and then extend the line until it parallels your position, ship's position. So point R to M. So and label this line as your RML, or the relative motion line. So RML. And the next is to get your DRM. You will transfer this line to your position, or at the center of this plotting sheet. So with the use of your triangle ruler, we will transfer this one. From here, we have drawn our relative motion line by connecting or drawing a line from point R to point M, and then extend that line until you reach your ship's position, and then in getting the DRM from your RML, drag that to your ship's position, and then read the bearing. So here, gonna do, this is our RML, and then slide this one to here. Then gonna draw a line, and then from here, our DRM here is 294, 290, 291, 292, 293, 294. So our DRM will be 294 degrees true. So this is our DRM. And the next is draw a 90-degree angle from your ship's course to your relative motion line. So from here, draw a 90 degrees intersecting the RML into your ship's position, and then label this one as your CPA, and then extend this line and to get your CPA bearing. So your CPA will be 22 degrees. 22 degrees true, and then CPA distance. In getting the CPA distance, get your compass divider and measure from RML to your ship's position. Transfer to the distance scale and read the measurement. So I have 3.6. 3.6, and then we're gonna solve the SRM as well as the time of CPA in minutes. So for the SRM, the formula for this one is from the DST, so distance from R to M over time interval. So distance from R to M, we measure R to M. So we have 2.2 nautical miles, so 2.2 over time interval of 0.1. Why 0.1? Because 6 minutes will be divided into 60, then the answer that is 0.1. so that's your time interval, and then you'll get your calculator to solve your speed of relative motion. So 2.2 divided by 0.1 is 22 knots. 22 knots SRM. So we have our SRM. Next thing is to solve for the time of Dcpa. So the formula for this one, Dcpa, is distance from CPA to M over the SRM, then times 1 to 60 to have your answer in minutes. So distance from CPA to M is, get your compass divider and measure from CPA. So we have here 9.5 approximate, yes, 9.5. Nautical miles over SRM of 22 knots, and then times that 1 to 60. So the TCPA will be 9.5 over 22 times that 1 to 60. So the answer would be 25 minutes. So 25 minutes. So 25 minutes. So here, from getting our CPA down to the time of CPA, this we have completed this exercise. by getting the CPA distance, CPA bearing, time of CPA, SRM, DRM. And that's all. I hope you understand this video. Thank you for watching. And again, I'm Cal Steven F. Kaime, and we'll see you guys next time. Bye bye.